Hello students, today we will see the experiment of surface tension. Aim of the experiment to determine the surface tension of a given liquid using staggerometer. Apparatus required: staggerometer. This is a staggerometer, rubber tubing with a screw, pinch cock, beaker. This is a beaker, clamp. This is a clamp, etc. Chemicals required for this experiments are: given liquid of known density, chromic acid, acetone, distilled water, etc. Theory behind this experiment: every liquid experiences a force at its surface which is totally different than the force experienced by the molecule at the center. This force is called as surface tension. It is defined as the force in dynes acting at right angles to the surface of the liquid along unit length. Usually surface tension measured by a drop weight at staggerometer method. In this method, a drop forms at the end of capillary tube. When the drop falls, the downward force on the drop is equal to the force acting upward. Procedure: clean the staggerometer with a chromic acid. We can also clean it by using acetone. Dry it by passing hot air through dryer. Rinse it twice with a given liquid. Attach the rubber tube to the upper end of the staggerometer. Loosen the pinch cock screw and clamp the staggerometer to a stand. Take a given liquid in small beaker and bring it near to the other end of the staggerometer. Suck the liquid with mouth a little above the mark A. Allow the liquid to trickle dropwise. As soon as the liquid arrives at point A, start counting the number of drops falling until the liquid reaches point B. Note down the total number of drops. Repeat the same procedure at least 3 times. Finally, drain the liquid from staggerometer and pour it in bottle from which you are taken. Wash it with distilled water, rinse it with distilled water, and repeat the same procedure as above for distilled water. Exact process: this is the staggerometer shown here. One end of the staggerometer is a capillary end. Now the exact process is carried out in such a way that a staggerometer is attached to a clamp stand. Dip a capillary end of a staggerometer in beaker containing solution and suck through another end above the mark A. This is mark A. Allow the solution flow down dropwise through capillary end. Measure the number of drops from level A to level B. As soon as the level B reaches, stop measuring number of drops. This is level B. Repeat 3 times and record the number of drops in observation table. Repeat the same procedure with water. The process can be shown like this. This is the staggerometer attached here. As soon as the liquid level reaches at a first mark, that is level A, start to measure number of drops. Allow to flow the liquid dropwise up to level B. Stop the measuring of drops. Now up to level B, if it comes, stop the measuring of drops. Record the number of drops in observation table. Observation table is like this. Liquid, that is given liquid and distilled water. Density rho 2, rho 1. Rho 2 for given liquid, rho 1 for distilled water. Number of drops, 3 readings we should note, 1, 2, 3, and finally mean of these 3 readings. And surface tension mu2 for given liquid, mu1 for distilled water. Now calculations. Relative surface tension of given liquid can be calculated by using formula mu2 is equal to rho 2 into n1 divided by rho 1 into n2 into mu1, where mu2 is the surface tension of liquid, mu1 is the surface tension of water, which is 71.97 dynes per centimeter at 25 degrees centigrade. Rho 2 is the density of liquid, that is given. Rho 1 is the density of water, which is literature value, that is 0.997 at 25 degrees centigrade. N2 is the number of drops for liquid. N1 is the number of drops for water. If we keep this value in formula, we will get mu2 is equal to dash dash dynes per centimeter. The results in such a way that surface tension of given liquid is equal to dash dash dynes per centimeter. Hope you understand. Thank you. Bye bye.